In this video, we're going to look at how to use your calculator to find your binomial distribution probabilities, so you don't have to use that long formula with your NPRs and NCRs and factorials. A binomial distribution is kind of breaking up the probabilities. A lot of times we talk about a success and a failure rate, so like left or right, up or down, male or female, but we can break them up into different sections too, and say, maybe, for example, in this problem, I asked 7 people out on the street, hey, do you recognize the symbol? I assume that I have a 60% chance that they'll recognize the symbol, that P would be my success rate that you'll be given. And I want to know that exactly, what's the probability that exactly 6 will recognize it? And so that's how we'll read these problems. And it's given to out of order, if you will, on my math lab, because when we put it in our calculator, we're going to say N, P, and then X. And a lot of times you'll hear me say R because I think about it. I have this many things and I want this many, kind of like when we did with permutations. And NPR is easier for me to remember because of the radio station. So to find your probability distribution, we're going to go into second vars, which is our distribution menu. Scroll down to binomial PDF. You can use binomial CDF for some things. I don't like to use CDF. I'll always just use the PDF, and we'll look at that in the last question of how to work with that. Highlight binomial PDF, hit enter, and bring it back to the main screen. If you are using one that has a more updated operating system, you're going to have like a sub-screen that you'll have to fill out. N is the number of households or number of people, or then just the number of things that you're surveying, comma P, which is your success rate, and then last is going to be your X, and that's going to be the specific outcome that you're looking for, assuming that we have one. So in this case, comma 6, close your parentheses. And when you hit enter, you'll get your probability. Round to 3 decimal places, so 0.131. So about 13% chance that I'll get what it is that I'm looking for, to have exactly 6 people recognize out of the 7 that I asked, given that my success rate is a 0.6. Sometimes they don't give you all of this information, and what they'll do is they'll give you this little box, say here's N, here's P, and they'll give you this long list of probabilities. So in this case, I had a clinical drug. 14.6% of the patients were treated with this drug, and 14.6% of the patients that were treated with the drug had headaches. So I take 5 subjects from this study, like a subsample. I treat them with the drug, and I want to see, how many people had a headache. And so the likelihood that 0 patients will have a headache, about 45%, 1 about 39%, and so on. And so when they give you this list, it's really just a matter of reading the question and seeing what it is that they're looking for. So what's the probability that more than one subject will have a headache? More than one, so 2, 3, 4, or 5. And then really all you need to do is take out your calculator and add up those numbers. So more than one would be 2, 3, 4, and 5. So about a 1575. And so with those questions, a lot of times it's just a matter of reading it to see where am I adding up to, or where am I adding up from. 4 is like that. 6 is a little bit different. With 6, they want to know a couple of different things, as you'll see in a minute, but they didn't give us the probabilities for all of them. So what we'll have to do is find them. We had this fictional show, Lindsay and Tobias. They had a share of 15, meaning of the sets in use at the time, 15% were turned into the show. So we want to verify the 15%, and we do this pilot survey with 17 households. And so I have 17 households with a 15% success rate. What's the probability that none of the households were tuned into the show? So second vars, binomial PDF, 17 households, 15% success rate. What's the probability that none of them were turned in? So that's 0.063. So about 6% chance that nobody's watching the show. I guess that's pretty bad. What's the probability that at least one household is turned in? And that's where, when we were talking about at the end of 4, the idea of being disjoint. 0 is the disjoint set of at least 1. So anything but 0 would have to be from 100%, take out just the percent that had the 0. Now, if they wanted to know like more than 3 or more than 5, say, what you would do in your calculator is you would run this again, binomial PDF. You would say 17, success rate of a 0.15, but then leave out the X value. And on your screen, it's 15%, not 50. Leave off the X value if you have the newer calculator. And when you hit enter, you're going to get this long string of numbers, and you see the 0% right there. What you're going to want to do is store that list into L2. So you hit second 2, and when you hit enter, it's like, all right, I'm in there. Hit stat and then edit, and then you'll see all those numbers in there. And I like to put it in L2 because then what I can do is move this over and say this is my percent for 0. 1, 2, oops, 2, 2, 2, 2, 2. 3, 4, 5, 6, and then all the way up into wherever I need to go. You'll always have one more probability than what number of households or than your n, because you have to consider the 0. And then what you would do if I wanted to know from at least 1, so from 1 up, I could add all of these up. But because I'm talking about the disjoint set, I know it's everything but that. So 1 minus the probability of the 0, which was 0.63. So 0.937, 0.937. What's the probability that at most one household is tuned in? Well, let's go back to this. Stat edit. At most one would be 0 or 1. So 0.63 plus a 0.189. So at most one would be 0 households or 1 household, so 0.252. And my rounding might be a little off. Let's see what happens. And we're good there. And the last part is, if at most one household is turned in, does it appear that the 15% value is wrong? Let's see. This one was tricky. Yes, because the household was greater than the 5%, I think. Nah. These are always hard. So no, because it was less than 5%. There we go. No, because with that rate it was greater than the. Oh yes, the 15% was greater than the 0.5. So that makes sense. That is in 5.3. In 5.4, if we can get there. It's a little more open-ended. Where they give you just N and P's and say, all right, find all of these different values. First of all, your usual values are the same as before, plus or minus 2 standard deviations. But you don't need to go through the process of putting your N and your P and getting all the values and then finding the average from there. The average with a binomial distribution, and which will be important for your lab, is just the number that you're working with times your success rate. That's your average. That's also your expected value, which is a little bit more of the terminology that you see on the lab. So my average for this would be just 140 times a 0.6, or 84. If I want to know my standard deviation, I also have another little shortcut for that, so I don't have to run all those probabilities and then run 1vars. Standard deviation is N times P times Q. Now, Q is the disjoint of P, so it's the failure rate, if you will. So if P is 0.6, Q's got to be 0.4. It's going to be the square root of this number, so multiply those numbers together and then take the square root, and you'll get your standard deviation. We'll go 1 decimal place, 5.8. Now that you have that, you can say, okay, I have my average. I can say what would be the value for 2 standard deviations down, and what would be the high end for 2 standard deviations up. 95.6. That's really pretty much it. It's really not so bad. Now, if let's say like on your lab, you weren't sure about that, and you don't necessarily have all of these rates, you can, I'm going to clear out my calculator because I have a ton of stuff in my list. I can go to second vars, binomial PDF. 140 is too long. Let's pretend it's 10. And then make it a 0.6. And then get all of those values. Store that into L2. And when you go in there to stat edit now, you'll see those in there, and I can count up and say, all right, the probability of getting 10 out of 10, given the 60% rate, is that 9 would be this, 9 would be that. And if I want to know the average and the standard deviation so that I can do what I did here, I can now then go out to the main screen, go back into stat, and go over to calc, and we're going to run 1 vars, but the trick is you got to tell the calculator that L1 is what could happen, and L2 is the probability that it will happen. So you have to say second 1, fill up my L1, and link it to the L2 like that. Then you'll get your average of a 6, which 10 times 0.6 is that. 10 times 0.6 times 0.4, square root of that. Oh, where the heck did that come from? Will give you the same standard deviation. So if you have all of them, you can use them. If you have just this information, you can kind of skip that and go from there. What we just did will be helpful for your lab, but on your homeworks, you'll be able to use the shortened formulas.